Okay, so today we are doing a whole bunch of examples of all of the skills from 3C, which we're all building up to finding all of the zeros of a polynomial function. And we have lots of tools in our toolbox. When I'm looking at a function, what's the first thing I should do when I'm trying to find its zeros? I should check to see that it is, starts with an F, factorable. If it's factorable, let's factor it. Solving by factoring is the fastest, right? So if it matches a factoring pattern, difference of squares, difference of cubes, sum of cubes. If it's got 4 terms and it looks like I can factor by grouping, if it's quadratic, I can play the X game. Yeah, factor it first. If I can't factor it, that's when we grab for the rational zero theorem. We make a list of all the possible rational zeros. We plug them in using the remainder theorem to check for which ones have remainders of 0. And then we use synthetic division to divide out the rational zeros. And the hope is that what's left will be a polynomial that we can either factor or use the quadratic formula on. Yeah? So we're going to do that process a couple times, starting with this guy. Is this polynomial factorable? No. He's a cubic. He's not a squared. Can't really do much with him. So we don't know how to factor him with the tools we have in our toolbox. So the next thing we're going to do is we're going to make a list of all of our rational zeros. And we know that our list of possible rational zeros come from 2 numbers, a0 and an. A0 is our constant term. What's our constant term for this polynomial? -1. Very good. So a0 is -1. An should be the coefficient of the leading term. Who can tell me what our leading coefficient is? 4. Very good. Aubrey is on fire today. I want to make all my fractions with the factors of those numbers. Factors of 1 are nice. 1 in itself, so plus or minus 1. What are the factors of 4? 1 and 4, so plus or minus 1. Plus or minus 4. What else? 2. 2 and 2. So plus or minus 2. A0 on top, an on bottom. I get plus or minus 1 over 1 is just 1. Plus or minus 1 over 2, so plus or minus 1/2. And then plus or minus 1 over 4, so plus or minus 1/4. And I need to know which one of those is an actual zero. So I'm going to use the remainder theorem. I know that if I evaluate my function, f, at those numbers, my zeros occur where my remainder is 0. So I want to know what f of -1 is, f of +1, f of -1/2, f of +1/2. I'm going to need to write the positive there. And then f of -1/4 and +1/4. There are 2 ways that we talked about how to do this last week. We know we can evaluate the first guy using the formula for -1 cubed minus 3 times -1 minus 1. And then we can go up, copy, paste, and then retype the numbers. We can also make a list. I'm going to put a couple minutes on the clock. I want you to calculate those 6 remainders. Don't stare at it like you're not here today. Come on. Good morning. I'm going to put a couple minutes on the clock. You're calculating remainders. I know. It's the end of the quarter. We're all tired. I don't know, but you have one coming up, not this coming weekend, but the weekend after. Let's see, 4 times second one cubed. Let's see, minus 3 second one minus 1. Oh, yes, Megan, yes. Do you need me to make it for you, Megan? Okay. You should check my work and make sure I did that correctly. You get to see who's fast with their calculator skills. Those of you who were on your calculator, can I get some confirmation for some of those? Getting thumbs up from Brandy, that's a good sign. Nodding from Ethan. Okay, I'm going to assume I did that correctly, in which case I spy 2 zeros. I spy a 0 here, meaning that this guy is one of my zeros. I have a 0 at x equals -1/2. And I see a 0 here, meaning my function has a 0 at x equals 1. Based on the structure of my polynomial, how many total zeros should I have? 3. Why 3, Ethan? Very good. Biggest exponent, or the degree of our polynomial, that's how many total zeros I should have. Some of them may be complex, some of them may be repeats. So we need to figure out what the case is here, because I only found 2. And the strategy is, once I find my rational zeros, I divide them out with synthetic division. So now we're on familiar ground. We're just going to do synthetic division with those 2 zeros. So I'm going to start with my x equals 1. So I don't need to change the sign, because this wasn't x minus 1. This wasn't binomial. This was just x equals 1. 1. And then I need the coefficients from the binomial. So I have 4x cubed. Do I have an x squared term? No. So placeholder, and then -3x, and then -1. And I know that last column should be my remainder. And what remainder am I expecting? 0, because this is a 0. Yeah. So we bring down the 4. 1 times 4 is 4. 0 plus 4 is 4. 1 times 4 is 4. -3 plus 4 is 1. 1 times 1 is 1. -1 plus 1 is 0. Yay. So these are the coefficients on the reduced polynomial. 4x squared plus 4x plus 1. And now I want to divide out the second 0, meaning these will be the coefficients inside, and I'm going to divide by the second 0, x equals negative 1/2. And what should my remainder be? Whole class with confidence, 0. Very good. This should be 0. Same process. Bring down the 4. What is negative 1/2 times 4? Negative 2, yeah. 4 plus negative 2 is 2. Negative 1/2 of 2, negative 1. 1 plus negative 1 is 0. I have a way to figure out my last 0. This represents 4x plus 2. Where does 4x plus 2 equal 0? So I move the 2 over. And divide by 4, yeah. And I happen to know that can be reduced. Both are divisible by 2, so that becomes negative 1 over 2, which we already found. What that means is this polynomial only has 2 real zeros. So zeros at x equals negative 1/2 and x equals 1. And I want to be able to indicate to other mathematicians that one of those repeats. And we indicate that a 0 repeats through its multiplicity. New vocab word. This guy repeats twice. So the root at x equals negative 1/2 has a multiplicity equal to 2. Multiplicity is how we indicate that roots repeat. If it repeats twice, it has a multiplicity of 2. If it repeats 3 times, it has a multiplicity of... I'm glad we're all awake today. 3 times would be 3. If it repeats 5 times, it would have a multiplicity of 5. If it repeats 1 time, what's its multiplicity? 1, yeah. Yeah, so this guy here that only showed up once has a multiplicity of 1. Yeah. I should always have the same number of roots that I have degree of my polynomial. Sometimes they'll show up as repeated roots. Sometimes they'll show up as complex and not real. But I should always have the same number as my degree, yeah? Okay, questions before we try one more? Shaking our head no. Okay. Number 2. Come on, pen. So f of x equals 3x cubed plus 9x squared plus x plus 3. First question, is that factorable? So I'm going to have you vote with your thumbs. If you think that it might be factorable, you're going to give me a thumbs up. If you think that it's probably not factorable, you're going to give me a thumbs down. I want to see thumbs in 3, 2, 1. are more thumbs down, but the thumbs up are correct. That is factorable. We're going to factor that guy by grouping. So I'm going to look at just the first two together, just the second two together. What do the first two have in common? 3. How many x's? 2. Pull out an x squared. So that's going to leave me with an x and a 3. Did I do that correctly? I heard very quiet. Very good. Second pair of terms, do they have anything in common? No, when they don't have anything in common, I can pull out a 1. Because 1 times anything is itself. So 1 times x plus 3 is just x plus 3. Takes me back to where I was. And I see something that makes me happy. They are the same, and that's how factoring by grouping works. I'm going to factor out the binomial they have in common. And the leftovers from the first term, I get a 3x squared. Second term, I get a plus 1. That is the question. I want to know where this guy is 0. And the 0 product property tells me either the first binomial is 0 or the second binomial is 0. We have to solve both. We're going to get zeros from multiple places. For x plus 3 equals 0, I subtract x from both sides, and I get x equals -3. We agree, good. The next one, I'm going to have to do a little bit of algebra. First step. What should I do, Jade? Subtract the 1. So 3x squared equals -1. Very good. Alex, what is the next suggestion? Reverse PEMDAS. What comes before we get up to exponents? Good. Undo the multiplication. So divide both sides by 3. -1/3. And then we can take a square root. Square root of x squared is x. On the other side, remember that when you take the square root of a number, you pick a plus or minus up in front. And that is technically correct. You won't see any math teachers leave it like that, but that is technically correct. How many zeros have we found? I see 3. I see 1 in the x equals -3. How many are sitting here? 2, a plus and a minus. So there are 3 total, yeah. Which is good because this was a degree 3 polynomial. If you wanted to be a proper mathematician, we could massage this a little bit until it looked a little prettier. First, when we see a negative under the square root, and square root of -1 is called what? What nickname do we have for that? I, yeah, I. So I square root of 1/3. Again, technically correct. Mathematicians do not like radicals in the denominators of fractions. So what most mathematicians would do at this stage is they would multiply top and bottom by √3. That is the question. Makes a fraction, that's for sure. On the bottom, what is square root of 3 times square root of 3? Square root of 3 squared. What happens to the square and the square root? They cancel. We just get 3. On the top, 1 times anything is itself. So this is just going to be square root of 3. I would give you full credit if you got to there on the test. But you should know, as pre-calculus students, big adult mathematicians would write it this way. We are going to do some more practice tomorrow. I would like you to practice this long form on your homework. Your homework's going to ask you to do that on Delta Math, yeah? To get to Canvas, you're going to need to reset your password. If you don't know what your password is, or you didn't get that email from Canvas, email Selena at Hartnell. You took a picture of her email, yeah? Yeah. Email Selena.